Hello, this is the correction of worksheet 3, which is about section 3.1 and 3.2. So we start with the first MCQ question. We have here the function is y equal to x squared times ex. So we want to find the derivative of this function. Since it is, in fact, product of two functions, so we will apply the product rule, which is f times g prime equal to f prime g plus g prime f. Okay, I will write here the rule. So f times g prime is equal to f prime g plus f g prime. So we alternate the derivative between the two functions. So y prime here will be equal to derivative of x squared. F here is x squared and g is ex. We know that the derivative of x squared is 2x multiplied by g, which is ex, plus f, which is x squared multiplied by g prime, which is ex itself. So we can put ex in factor. So factor x squared plus 2x. We can, in fact, also put even x in factor, but since we have the answer here, so the answer is B in this case. Okay. Now the next MCQ question will be about the function f of x is equal to x power 5 plus, sorry, x power pi plus pi over power 5. So if we use the rule of the sum of two functions, we observe here that the first function is, there is a variable x, but the second function is in fact a constant, like a number. So the derivative of this one, okay, there is a variable x, plus the derivative of this one, which is a constant. So the derivative of the second part is equal to 0. So f prime, in fact, and be careful here, since there is no variable in the second one, so the derivative is 0. And the first one, I will apply the rule of x power r derivative, which is equal to r x r minus 1. Okay, so it is pi x power pi minus 1 plus 0. So the answer clearly is C here, since we can forget this 0. And the next derivative that we will compute is the function f of x is equal to ex over x plus ex. So this is in fact the quotient rule. It's an application of the quotient rule. I will each time I will try to recall the rule that we will use. So here f over g prime. First, when you have quotient, you write the denominator squared. And in the numerator, it's like the product, but there is minus. So f prime g minus f g prime. And here, be carefully of the order, because you will differentiate first the function f, which is here, the first one. Okay, since there is a minus, so the order is meaningful here. You have to pay attention to the order. Now, when we apply this rule, okay, so I have f prime of x equal to, so first I will put my denominator squared, so x plus ex squared, And then in the numerator, I will have derivative of ex, which is ex itself, times the denominator without derivative. So x plus ex. Then minus the first one without derivative, ex, times the derivative of the function in the denominator, which is x plus ex. So the derivative is 1 plus ex. And now I will put ex in factor. You see here, so I will have x plus ex squared. This is in the denominator. And in the numerator, so I lost this, so ex. Then when I put ex in common factor, so clearly I will have x plus ex minus 1 minus ex. Okay, so when we simplify ex minus ex, clearly I will have x minus 1 times ex over the denominator squared. So the answer is C again here for f prime. Okay, now I can move toward to the MCQ number 4. I want to find the limit of ex minus 1 over x. Remember the definition of the link between f prime and the derivative. So in general, I have f prime of x is equal to the limit when h approaches 0 of f of x plus h minus f of x over halving over h. So my limit is h approaches 0. Imagine you have the f of x is ex. So my result here will be limit ex plus h minus ex over h. This will give, in fact, the derivative of ex for all x. Now what I want to apply here is, okay, I want to apply at the point x equal to 0. Okay, so I will have the derivative of ex, which is equal to ex itself, but the application of this computation at the point x equal to 0 will give me limit exponential h minus 1, since x equal to 0, over h, when h approaches 0, is equal to 1. And this is exactly what we want here. Take the limit h approaches 0 or x approaches 0. It's a variable, so it doesn't matter. The result will be number C, which is equal to 1 here. Okay, so now we can move to the essay. So question number 1, find a and b that makes the following function continuous and differentiable at 1. First, we will start with the continuity. So if we want to have the continuity of this function at 1, so we must have limit to the right equal to limit to the left equal to the value of f at 1, and f at 1 here is equal to 1. And this is, by the way, the value to the left of 1. It must be also equal to the limit when x approaches 1 plus, that means a plus b. So this is the first condition on a and b to have the continuity at 1. F differentiable, now we see that the derivative of f of x by interval, it will be a if x greater than 1 and 2x if x less than or equal to 1. So if we want that this function will be differentiable at 1, I will have this condition. So a equal to 2. And here from the first equation, I will find that b is equal to 1 minus 2, so b equal to negative 1. The next question, find the equation of the tangent line and normal line to the curve y equal to this quantity. So first we compute the derivative. Y prime is equal to 2x over 4, that means half x, plus 2 times the derivative of root x, which is 1 over 2 root x. So in total, I will have half x plus 1 over root x. And we will take the point x equal to 4 here. So x equal to 4. That means y prime is equal to 4 over 2. That means 2 plus 1 over root 4, which is 1 over 2. So the value here is 2.5. That's the slope of the tangent line, and the equation of the tangent line, it will be here to make more space. Okay, then I will have the tangent line. Its equation is of the form y minus the value of the point 4, so f of 4 equal to f prime of 4 times x minus 4. Okay, it's like I put f of x is this quantity. Okay, so f of 4 here, if I replace x by 4 and I compute the y, I will find 4 squared, that's 16 over 4, that means 4, plus 2 times the root of 4, so 4 plus 4, this is 8, equal to f prime of 4, which is 2.5, that I will write 5 over 2, times x minus 4. And if I want to simplify this equation, I will multiply everything by 2, then it will give 2y minus 16 equal to 5x minus 20. So this means that it is 5x minus 2y equal to minus 16 plus 20, that means 4. That's the equation of the tangent line. By the way, here we can express also the tangent line as in the slope-intercept form. So it's very easy here, since from this I will return to this form here, and from here I will put like it is equal to y equal to 5 over 2x. I will expand the one to the right, minus 5 over 2 times 4, that means 10, and plus 8. So this gives me 5 over 2x minus 2. This is the slope-intercept form of the tangent line. However, the normal line is easier normal line, because I know that the slope of the normal line will be the inverse of the slope here, this one. So make it a bit 2 over 5 and add minus. So the equation will be y equal to minus 2 over 5x plus answer certain b, which is the intercept point here for the normal line. How to find the b in this equation? That's simple. Just replace the point, which is 4, and f of 4, we computed this, is 8. So for 8, okay, that's the point. This gives that 8 is equal to minus 2 over 5 times 4 plus b. And solve this equation for b. And you will find that after doing some computation, let me put some space again here, 2 lines. So this gives, let's multiply by 5 everything. So I will have 40 equal to minus 8 plus b. Okay, so that means that b is equal to 48, 5b, sorry here. So b is equal to 48 over 5, and that gives the equation of the normal line, which is y equal to minus 2 over 5x plus 48 over 5. That's the final answer for the normal line. Okay, so we found the tangent line equation and the normal line equation. Look at question 3 now. This is like application of the rules of sum, difference, product, quotient. Just you apply the rule and you replace the value. Look at this, for example. And here we want to find each prime of 4. So first, write each prime of x, which is equal to 3 f prime of x plus 8 g prime of x in the case A. So now replace with the 4. So it's 3 f prime of 4 plus 8 g prime of 4. You have the value of f prime of 4 here, 6. G prime of 4 minus 3. So you replace. And you will get equal to 3 times 6. And be careful here because you will have many values. So be carefully to choose the right one. F prime of 4 is equal to 6 plus 8 g prime of 4, which is minus 3. So in total, you will have 18 minus 24. That gives minus 6. And this is the answer for A. Now, what about B? I will write directly. It's the rule of the product rule of derivative. So each prime of 4 will be f prime of 4 times g of 4 plus f of 4 times g prime of 4. Okay? And I have all the values here. F prime of 4, this is 6, times g of 4, which is 5, plus f of 4, which is 2, times g prime of 4, which is minus 3. Now computation. 30 minus 6, that means 24. For C, h prime of 4, I didn't write the rule, but just make the application directly. So it's g of 4 squared. And here, f prime of 4 times g of 4 minus f of 4 times g prime of 4. And now we substitute f prime of 4. Let's start with the denominator. G of 4 is 5. So it's 5 squared, 25. Okay, and then in the numerator, f prime of 4, 6 times J of 4, which is 5, minus f of 4, which is 2, times G prime of 4, which is minus 3. And here, don't make mistake for the signs. So 6 times 5, this is 30. 30 plus 6, so 36 over 25. That's the final answer. You can also proceed to D. So it's the same thing, h prime of 4. I'll write apply directly in 4. So the denominator squared, f of 4 plus g of 4 squared. Okay, because this is the denominator anyway, you will square it. And now in the numerator, you will start with g prime of 4. G prime of 4 times f of 4 plus g of 4. The function which is in the denominator. Then there is minus. I will continue here. The one on the numerator, which is g of 4 without derivative. So times the derivative of f plus g, but derivative of f plus g, this is f prime plus g prime. So f prime of 4 plus g prime of 4. Okay, now computation. It's 4 plus 3 of 4, the sum, so it's 7. 7 squared, that means 49. No, g prime of 4, this is minus 3, times the sum, which is 7, minus g of 4, which is 5, times the sum of the derivative. The sum of the derivative, 6 plus minus 3, that means 3. And now, finally, it's minus 21 minus 15 over 49. Then it is minus 36 over 49. That's the final answer. We cannot simplify because there is no common factor between numerator and denominator. Okay. Now I will continue with the example question 4. Okay, so here, now this. So for question 4, we have the function and we want to compute y secant for this function. Okay, so to compute the second derivative, you need all the time to compute the first derivative first. Okay, so I need here, in order to simplify the computation of the derivative, I will change the expression of y, since I don't have sum or difference in the numerator, in the denominator, sorry, here, I have root x, square root of x. So that means I can separate. So it's x squared over root x plus 4x over root x plus 3 over root x, that I can write simply with power of x. So x power 3 over 2 plus 4 power x half plus 3 power x minus half. Then it becomes more easier to compute the derivative here. Y prime is equal to 3 over 2, x power 3 over 2 minus 1, that means half, plus 4 times half, that means 2, x power half minus 1, that means minus half, and then plus 3 times minus half, that means minus 3 over 2, x power minus half minus 1, minus 3 over 2. Then the second derivative, now it becomes easy also, but be careful to multiply the powers. So 3 over 2 times half, that means 3 over 4. Don't make mistake in this computation. X power half minus 1, that's minus half. Plus 2 times minus half, 2 times minus half, that's minus 1. and minus 1, I will not write the 1 since I multiply by the x power minus half minus 1 minus 3 over 2. Then minus 3 over 2 times minus 3 over 2, which will give plus, and 3 over 2 times 3 over 2, that's 9 over 4 x power minus 3 over 2 minus 1, that means minus 5 over 2. And this is the final answer for the second derivative. I will move to question B then. And that's the last question here. Find the formula for the any order of derivative for 1 over x. And here it's like y equal to 1 over x. So better to write this x power minus 1. Then the derivative become easier. Y prime is minus 1 times x minus 1 minus 1. That means minus 2. This one, we can get rid of this one. No need to write it. Y second is equal to minus minus 2. That means 2. X power minus 2 minus 1. That means minus 3. Y third derivative, 2 times minus 3. That's minus 6. X power minus 3 minus 1. That's minus 4. And y power 4. It will give minus 6 times minus 4, that means 24. And x power minus 4 minus 1, that means minus 5. And you see here that the order is getting all the time plus 1 with negative sign, plus 1 with negative sign, plus 1 with negative sign, and so on. So I can conclude that my nth derivative, there is something like that. X power minus n plus, minus n, if the order is n, is minus n minus 1, okay? So imagine you have n equal to 2, then you will have minus 2 minus 1, that means minus 3. So that's correct. The only thing that it is maybe here difficult is to find the coefficient in front of x. So clearly there is plus, minus, plus, minus. When I have order 1, that's minus. When I have order 2, that's plus. When I have order 3, that's minus. So it's a question of odd even, and I can write it minus 1 power n. That will give me when n is odd, so it's minus. When n is even, it's plus. Now the coefficient in front of the x here, 2, 6, 24. So for 2, I have 2. For 3, I have 6. For 4, I have 24. This is the formula, in fact, n factorial. So in total, I will write it correctly, minus 1 power n factorial, x power minus n minus 1. That's the derivative of this function at any order n. Thank you so much. And next, I will do the next one.